Hey there, y'all. We're going to look at 6.3b today on solving linear systems by elimination. And so our objective is that you'll be able to solve systems of linear equations using elimination. And so we're still in the same objectives and standard that we've been looking at yesterday. And so speaking of yesterday, let's talk about what we learned yesterday. Remember that we said our steps were this: to be able to add or subtract the equations to eliminate one variable, and then solve for the other variable. So again, we're going to add or subtract the equations together to eliminate one of the variables. So if we see like 3x and 3x in our two equations, we would subtract those to get it to cancel. Our second step was to substitute the value into either equation that we found to find the other variable. So again, if we eliminated x, we found the y, and now we're going to substitute that y back in to find the x. And of course, step 3 was to write that ordered pair for the solution. But what happens when the variables don't cancel? What happens if I have a problem like 3x plus 2y is equal to 5 and 4x minus 3y is equal to 6? Well, those don't line up. Nothing cancels, right? And don't tell me that you're going to deal with the 3's because one's with an x and one's with a y, right? So we have to add a step in front of our step 1 from yesterday. And so we'll call this step 0. And step 0 is that we're going to multiply one or both equations so that the coefficients of one of the variables are either the same, and we'll do subtraction, or have opposite signs so that we can do addition. And so those are our steps we're going to look at today, and I've got 3 examples for us, okay? And so example 1, 7x minus 12y is equal to 0, and negative 2x plus 4y is equal to 12. And so in this case, we're going to multiply one of the equations by a value to get the variables to line up. Now, look at the x's. I've got 7 and negative 2. What can I multiply 2 by to get to 7? Well, if you're thinking about fractions, you could say 7 halves, right? Because that would get it there. But normally we don't like to deal with the fractions because a lot of times it's going to introduce fractions to our problems. So we want to deal with that. Let's look at the y's. 4 times what gives us 12? 4 times 3 gives us 12, right? And so I'm going to multiply the entire bottom line, not just by 3, but by negative 3. And here's why negative. Currently, both signs are negative. If I multiply the bottom line by a negative, then I'm going to get it to where the signs will be different, and I can do addition and not subtraction. And again, remember, addition's easier to deal with these problems than subtraction. And so here's my next line. The first equation we didn't do anything to, so we just copy it down. 7x minus 12y equals 0. Our second equation is the one that we multiplied by negative 3. And again, everything gets multiplied by negative 3. Remember, what we do to one side of an equation, we have to do to what? The other. And so I'm going to get 6x plus 12y is equal to negative 36. Because again, we multiplied everything by that negative 3. And so now adding these together, I get 7x plus 6x is 13x. Negative 12y and positive 12y will cancel. 0 and negative 36 added together is negative 36. Now, we can divide both sides by the 13. And so we get that x is equal to negative 36 over 13. Now, that will not reduce. And so we're going to have to deal with that in the second part of our problem. And so we're going to take all of this and substitute it back up here for x. Now, we could deal with it in the first equation or the second equation. I like the first because it's set equal to 0, and so that's going to make the solving this a little bit easier. And so I'm going to get 7 times the negative 36 over 13 minus 12y is equal to 0. When we do the multiplication here, we're going to get 7 times 36. 7 times 36 is going to be 252. It's still negative over the 13. Remember, this is over a 1, right? Minus the 12y equals 0. We're now going to add this across. That cancels. So we get negative 12y is equal to 252 over 13. We're now going to divide both sides by the negative 12. Now over here, when I do, on the right side, when I do the division, that's going to give us y is equal to 252 over 13 times 1 over negative 12. Because remember, if you're dividing by a fraction, you're really multiplying by its reciprocal, right? And so 252 does have a factor of 12 in it, and so that will reduce in a moment. But for right now, we're going to get the 252. It'll be negative now because the negative times the positive, and 13 times 12 is 156. And so dividing these both out by 12, we're going to get back to our 13 here, and dividing this by 12, we're going to get this down to 21. So this is negative 21 over 13. And so my final answer for the ordered pair is negative 36 thirteenths and negative 21 thirteenths. And again, I know some of you are thinking, oh my God, fractions. But guess what? That's the whole point of doing substitution and elimination. The whole point of doing these two methods is that you can find these solutions that are not precise answers. And so, again, I know this looks crazy, but that's the whole purpose. And this is high school, y'all. And I know you're going to complain, oh my God, fractions. Y'all. You got to be able to work with the fractions. You got to be able to practice these. You got to be able to do them. So quit complaining in your heads. Quit complaining out loud, because I know some of you doing it. And just do it, y'all. You got to be able to do this, because there's no way you're going to move on to higher level maths, even to geometry or algebra 2, and not be able to do fractions, y'all. I mean, you got to be able to work with them. So, all right. So our answer there is the ordered pair negative 36 thirteenths and negative 21 thirteenths. And so we could convert those to mixed numbers and find where it would be on the coordinate plane, but we're not graphing this today. All right, example 2, here we go. What happens if I need to multiply both equations by something, right? I can't multiply the 3 by something to get 5. Again, I could multiply by a fraction and get it, but again, we want to avoid multiplying by fractions if we can, because that'll make it guaranteed we have to deal with fractions in these problems. And I also can't multiply 2 by something to get 5. And so we're going to have to multiply both equations by a value, one value for the first equation and a different value for the second equation, to get these to the same value. And so what we can do is look at which one's going to be easier to multiply to a common multiple. Well, that's going back to middle school, right? The least common multiple. What's the least common multiple of 5 and 3? Well, 5 times 3 gives me 15, and that is the least common multiple, right? I could do the same for 5 and 2, and 5 and 2 would be 10. So it's a matter of which one do we want to multiply to. Do we want to multiply the y's to get to 10, or do we want to multiply the x's and get to 15? I'm going to multiply the y's to get to 10 in this case, because the top equation I will multiply by 2, because 5 times 2 is 10. And the bottom equation I'm going to multiply by 5, because 2 times 5 is 10. But remember, what you do to one part of the equation, you must multiply to the entire equation, both sides of it, right? And so our top line is going to say this. It's going to say 10x minus 10y is equal to 20. And our bottom equation, multiplying by 5, will give us negative 15x plus 10y is equal to 15. Now, the y's have different signs, so I'm able to add those together. So this will cancel. 10x minus 15x is going to give us negative 5x. And 20 plus 15 is 35. And so we're going to divide both sides by the negative 5. And so x is equal to negative 7. Okay? We're going to take that and plug it back into one of the originals. And so, first equation, second equation, it doesn't matter in that sense. I'm going to go with the second equation because the negative times the negative will give me a positive, and we'll work from there. All right, so I'm going to get negative 3 times the negative 7 plus 2y is equal to 3. And so negative 3 times negative 7 is positive 21 plus 2y is equal to 3. I'm going to subtract the 21. And so we get that 2y is equal to negative 18. I'm going to divide both sides by the 2, so y is equal to negative 9. And so I get negative 7, negative 9 for my ordered pair. So like you see here, some problems come out to fractions, other problems don't. But again, we're able to solve this out to find the solution. All right, our third problem, example 3, special system. So yesterday we looked at a problem about solving one by elimination, and we're going to look at another one today that doesn't come out to an ordered pair. All right, so in this problem, we need to determine what we're going to do to solve this out. Now, I want to show you a little bit of an advanced method here. Look at the second equation for a second. I'm going to highlight it. Could all of those be divided by something? You got 15x, a negative 5y, and a positive 10. Can all those be divided by something? They can. They can all be divided by 5. Watch what happens when we do that. So 18x minus 6y equals 11. And then I'm going to get 3x minus y is equal to 2. Now, look at that bottom equation. And what could I do to get these to line up? What can I multiply this bottom equation by to either get the x's to eliminate or the y's to eliminate? I can multiply the bottom line by 6. Because if I do 3 times 6, I get 18. Now, I'm going to use a negative 6 so that way the signs are different. And so my first line is still the 18x minus 6y equals 11. The second line will be a negative 18x plus 6y equals negative 12. 18 plus negative 18 cancels. Negative 6y plus positive 6y, well, that also cancels. So everything on the left canceled, which means my left side is equal to 0. There's nothing left. 11 plus negative 12 is negative 1. So I get 0 equals negative 1. Well, is that a true statement or a false statement? This is a false statement, right? And if it's a false statement, it means what's the solution? No solution. So there you have it. That's what we're looking at when we do elimination. And again, that's a little bit more of an advanced method, just dealing with simplifying an equation down, dividing it down first before multiplying it, which is a valid method because remember that division is just the inverse operation of multiplication. So really you're multiplying by 1/5 when you're doing that step. And so again, if you want to try that on some of these problems, you can. If you see something that will divide out of a problem, do it because it'll make your problem easier to do in the long run because you're dealing with smaller numbers, smaller coefficients. All right, so that's it for today. The word of the day is multiplication. Again, the word of the day is multiplication, and I hope you all have a great day. And I think I forgot to mention this in the announcement video, but my office hours today will be from 1 to 4, just because I've got some stuff going on this morning that I've got to take care of. So again, 1 to 4 today for the office hours, and it might be a little past 1, but be about 1 to 4. So y'all have a great day.